Swayam Prabha. Digital India. Educated India.
The point I was discussing for slope analysis, see, basically it is the gradient between the first one contour line to the next one. See, with respect to my two fingers, I am showing you. If this is one contour line and this is the next contour line, if they are close to each other, then the gradient of this particular surface is steeper, but vertical drop is same. If the same contour line shifts and comes here and then you join a line between this has become gentler. It is something like this, trying to cut a section through the contours. If I try to see the section through the contour, I would see only points. If I have drawn like this. Now, to give a little bit of idea about it, basically what you have drawn is each of this plate. These points are representing the plates. I hope this line is clear. Okay. The condition of this contour drawing is this is the dimension by which it is lowered from one to another. This is equal to this to equal to this to this to this. That means contour drawing in a contour lines in a contour drawing are at equidistant intervals vertically, but not necessarily the position of that in plan is at the same distances away. So, if it is not at the same distance away, then what happens is, if this is the first level, the next level you connect it, then you connect this, then you connect this here, then here, then here, then here, and then here. This gives us one information. That means the contour line, which is a cross section as a point, is at equal elevation down here and here, again up and up and up here. This drawing you do not try to measure exactly the length, because I am quickly drawing it, but basically if this was the plate, this was the plate and this was the plate and here, then this particular line is at an angle here. You will see higher the angle, steeper is the slope of that particular surface. This you can straightway infer from this understanding is that the contour lines, if they are closer, then the space or the surface between two contour lines are steeper. If they are apart, then they are gentler. So, if now I will show you a contour line, say I am just drawing arbitrarily. This, what you have to infer over here is first level, next level, next level and next level. They are very close to each other, This one is distant apart, but this is close here. It simply indicates that this is steeper, this is also steep, suddenly become gentler, and then you will see that it has become gentler, and after that suppose you find that the next contour is here. That means from steepness to the slightly gentler to a little more gentler to very gentle. Okay. So, slope is nothing to do with the levels. Slope is only the gradient of that surface between two parallel contour lines. This is very critical in one landscape project, and that is what is shown here in this particular diagram in the screen that you are seeing. Look at this particular screen in the slope analysis. You know what is done is, if you try to represent this, you can do it with the color or with the hatch patterns. If you do it with the color, and wherever it is steep, you give darker color in the monochrome. Say you select any color and find out the monochromatic range of that, and wherever it is gentler, you give lighter chrome of that, or wherever it is steeper, you give the darker chrome of that, by which if you fill up the whole area, then you will find that you can straightway indicate which portion is dark, which portion is steep, and which portion is gentle. Okay. Here, since it's a hatch pattern that I have selected as an example, in which if it is plain like this white, that means it is gentle. Check here, check at this particular point. Wherever the lines are closer, they are darker, and wherever the lines are apart along this, they are gentler. That is represented in a legend like this, in which if it is, say, steeper than 1 in 5, so this is closer lines, then 1 in 10 is this, then 1 in 20 is this, and then 1 in 50 is this, and then flatter than 1 in 50 is this. That means by this you can also subdivide much more. If you are not happy with these few gradations or divisions, you can make further subdivisions, no problem. Okay. If suppose this was absolutely flat, then what would have been the hatch pattern of this? White. And if it is of the uniform slope all along, then it would have had the same hatch pattern. Like an example, let us see, I am drawing here itself in the same page, so that you don't lose track of what was earlier. If suppose you find that the lines are closer, one example, if suppose I am drawing another, lines are apart but at equidistant. First level, there is another one, I have to draw one more line. First level is the highest level, the next level the same as this. This is, if suppose this is 5, 4, 3, 2, 1, and this is also 5, 4, 3, 2, 1. In such case, the 5 is here, the same level. The 4 is nearer, 3 is nearer, 2 is nearer, and 1 is nearer, and they are equidistant. Here 4 is slightly apart, 3 is little apart from 4, and then 2 is little apart, but all this apartness is equal. In such case, what will happen is you will try to find out what is the first level here and what is the one level here, and draw the line with respect to horizon. Okay. And for this one, this is the first level here, the first point here, and this is a one point here with respect to horizon. You try to draw the line, you will automatically find that this angle and this angle are different, and this angle means now it clearly indicates, pictorially clearly indicates that if the angle is lesser, then it is gentler, and if the angle is steeper, if the angle is greater, then it is steeper. And that if you represent with respect to the kind of patterns that is shown in this particular drawing, that if it is steeper, it becomes darker. So now if I look at it, this particular side, without having any idea about what is the contour elevation of each one of these contours, one can easily infer that this is a very steep area. Very steep is steeper than 1 in 50. This portion is steeper than 1 in 50 by this legend. This one is steeper than 1 in 50. So I should be now checking that what all functions can be placed over here with respect to its limits of slopes. Example, suppose in this particular site my client wants that I would like to have a play area, play field. Now you must have seen in the contour elevation I have already decided that the play fields are there, and now just check with the same drawing I am bringing again. If suppose I check that this is gentler because it is white, this is gentler, is white, that means it does not have a slope problem. So these are now befitting well in my contour slope analysis. So if I use a similar kind of drawing with respect to this, now see, this is slope analysis. Initially I was doing contour analysis. In the contour analysis I have found out these two locations are good for play field, and now when I am checking with respect to my slope analysis, I still do find this portion is play field and this portion is play field. isn't it? That means when I was doing this, I never referred to contour analysis. When I was doing this analysis, I never referred to slope analysis. Now I'm comparing for our clarity of understanding. I am comparing. Okay. Now in the slope analysis, basically what you will do is you will check all the functions that you have listed. An example, let me take the list that I have shown here. Don't look at the contour analysis, just take the list. Look at the list. Cottage, road, lake, overhead tank, orchards and playfield. Playfield needs flatter area. So any flat area within this sloped area I will consider worthy of playfield. Cottage, do I have to really go for flat area, or can the cottage be in the steep slopes? It can be in the steep slopes, because the cottages which you are placing over here, they can be on the stilts. So here essentially means pictorially, if I show you with respect to this drawing here itself, let me show you that if I have a sloped land like this with respect to horizon, I can always put the cottage over here with stilts. That means technically I will resolve it. So steepness is not really that a strong criteria beyond a particular limit. If suppose it is farther steep like this, where I cannot hold the cottage and I cannot make the props or stilts, then that particular section will not be selected. So you accordingly take this into consideration. In terms of slope analysis, again, water body, does it have to do really anything to do with the what slope? No, because in the water container, in the pond, it can be very steep slope at the edge, or it can be even gentler at the edge. So the thing is, still you can still find that wherever it is steeper and the lots of steeper areas are coming within the periphery, it automatically brings you down to this particular area which is for lake. Overhead tank, does it have to do anything with the slope? No. No. So overhead tank can be anywhere, because you are not following the elevation criteria when you are doing this. But one limitation, can you put an overhead tank at this steep slope here like this? Can you put an overhead tank on this particular steep slope? You cannot. So what happens is automatically all those steeper areas gets negated for my overhead tank location. Rest of the areas are fairly good enough. So here the idea is, when you are analyzing, you are not referring to the contour analysis that we have done before, and you are not referring to where you have found the potential locations for the rest. Keep it apart. Do it only for the slope and see what suits the best for slope analysis, and accordingly inferences, design criteria, checklist, compliance will come later. Okay. If the slope analysis has been fairly done, then you go for other analysis. Let's see what is next. These are different. See, slope analysis, this is one level of representation. Some people have used this kind of reference, this kind of representation. That's basically how you represent the best. Okay. Then comes the hydrology analysis. In the hydrology analysis, basically, what happens sometime in the hydrology analysis, people merge both. Means one is that the superficial hydrology and the subsurface hydrology, they do it with one particular set of analysis. But I would suggest that you do it. So that's why quite often the drainage analysis is synonymously used as the hydrology analysis. In my opinion and my experience of communications, I would suggest that never confuse this between these two. So the hydrology analysis you divide. One is subsurface hydrology and this top surface hydrology. Top surface hydrology is the one that you consider as the storm water drainage. Okay. But in this particular drawing which I have taken over here, it is basically in the hydrography, what they have shown is the streams and river, then drainage channels, major drainage channels and minor drainage channels. So here in this particular hydrography, it is referring to nothing but the same drainage or stormwater channels, okay, which I generally I am considering. Now let me take this particular picture. In this drainage analysis, what it is doing is, in this there are many other items which are shown here, the gas lines and the existing road, but this is showing in general the paths of the drainage. I'll show you another one. This is a drainage pattern on the watershed. When your landscape project is regional, in such cases you really don't go by the drains, you go by the watersheds. how the entire area's water is now coming into this. If you have seen the whole topography maps or topo sheets, you will realize, you will understand that it is a very broad level of information that is given over here. This is how the drainage pattern is shown, but I will show you with respect to this. Let's see if I have any more extra sheets. Okay, let me use this. Let me use this extra sheet for another contour analysis drawing. I will rather change this and I will write here drainage analysis. Okay. In this drainage analysis, what you do is, what you have to indicate. You have to indicate few important things. One is the watershed and sheet of water, the ridge, valley, okay, minor drainage channel, major drainage channel, area for susceptible to inundation, any water body, area susceptible to flooding, discharge points, okay. I am trying to write very fast, so you may not be able to read properly, but you have heard me. Watershed, a sheet of water, ridge, valley. Let me draw it here on this particular drawing. See, whenever, look at this particular drawing very carefully. Whenever you find that your curvature of the contour line goes outwardly from the top to the lower level, that means if this is the higher level and this is a lower level, and the curvature is convex towards down the hill, then all the center points of this curve, if you connect, they become the ridge. Let me, how it is represented. The ridge line is shown with dashed line like this. So if I try to identify the ridge over here, then this would be my ridge line. This would be the ridge line. This would be another ridge line. This would be another ridge line. This would be another ridge line. With respect to this, see, basically why I did not get or bring for you a pre-drawn things, because I am developing in front of you so that you understand that how you are going to develop in future. So whenever you see these curves in this direction, they are the ridge line, and if there is a ridge here and then the next ridge, then in between is from higher elevation to the lower elevation. If the curvature is inward, here the curve is outward, convex in nature. Here the curvature is inward, concave in nature. In such case, you connect all those central point, then it becomes a valley. The valley line you show with this. Okay. Now that means if this is my ridge line, this is another ridge line, and I am connecting this. All the center point is the valley. What has happened over here is, just a minute, sorry, this line will not remain as ridge because it has gone in, so this is going to go as a valley. Okay. Similarly, from here a line that comes like this goes to valley. Similarly, from here the line that goes like this goes to valley, and interestingly there is another line which will come like this as a valley. At least whatever I am seeing with respect to this drawing. So automatically you will find one thing: if there is a ridge, next is a valley, next is a ridge, next is a valley, next is a ridge. If you find any drawing which has a ridge and another ridge and there is absence of valley, the drawing may be erroneous, because it's basically, look at my hand, it is this particular point, ridge sloping in this direction, ridge sloping in this direction, this is the valley. So the valley then becomes designated as the channels. So whatever is your valley line, the moment you give an arrow, it becomes a channel. And channel means hydrological channel or drainage channel, whatever you call. And when you have many such channels, they are minor drainage channels. And when multiple minor drainage channel gets connected to another drainage channel, then this becomes a major drainage channel. I hope I could make the point clear. Once you do this, you try to find out the outfalls. Now let us see, with respect to this legend, what is watershed then? If this is a ridge, then that water which is falling on this particular surface, which is likely to fall on this and then follow the general contoured profile. Sometime it may be vertically from here to here, depending on this particular profile. This is that watershed and the sheet of water flow. Now that means water starts flowing from the ridge point to the lower slopes. From here, water starts flowing from the ridge point to the lower floor. Okay. Once you do this, you know that this water has to come here, this water has to come here. Then this water is getting collected by this particular valley, which is in a way is a minor drainage channel, and this water is coming to this valley, which is in a way a minor drainage channel sloping in this direction, because it is starting from the higher elevation to the lower elevation. So naturally this, the moment you give an arrow, this becomes a channel, and the best way to represent a channel is with the arrow. So which direction the water is flowing, that you have to be very, very clearly stating. Okay. Ridge does not have any arrow. Never by mistake give an arrow to the ridge, because ridge will give a wrong interpretation, but the valley it is. Okay, now if I go to this particular legend, watershed or the sheet of water flow that I have shown over here, the ridge I have shown over here, the valley I have shown over here, and then the minor drainage channel is this, and the major drainage channel is this. So major drainage channel also will have to have an arrow. So it is like, now my drawing is becoming complete, that water is coming from this to this, then flowing through this, getting connected with another one, coming to this, getting connected with another one, and then going in this direction. Then if this is so, then this is from my side, where this particular line, say look at this particular line, which is very faint at this particular point, but let me redraw. I have deliberately kept it faint so that you don't get confused with other lines which I am drawing. Okay, this is my sight line, and then with respect to this, this is the point where the water is being released. So this is my discharge point. So if I say this discharge point, basically from my side, this is my discharge point. None of these, because they are all originating points. This is a discharge point. Now suppose originating point I am saying with respect to my side, if suppose this particular thing, this is my sight line, if this line comes from here, this line comes from here, and this line comes from here, then you have to consider one thing. This is minor drainage channel to your site, but this site is also carrying the water from the region, from the next lands, the next lands, and to the next lands. All these becomes very, very critical. I will discuss all these things when I will discuss about the drainage design. Overloading of this information will not be very appropriate. So this is how you do it. So this is my discharge point. In case you find at the discharge point there is not much of good exit of this particular water, then automatically what will happen is, I am using the colors which may not be really very, very suitable for these, but however, when you find that the water that is not being able to discharge, but this is the lowest point of discharge, and the water is not getting the exit out, in such case gradually you will find that this will start collecting water, and this is then the zone which I will consider as the area subjected to inundation. This if suppose in my site I have found somewhere, I'm just trying to draw an example, somewhere I have found that there is a stagnant water body in which water is not being drained out, it is just contained within. This is the water body which I have listed over here. This is the area which is subject to inundation. In the water body, the water will remain fixed with subjected to little bit of variation because of the evaporation, but otherwise all the water is contained within. Inundation area is such where you will find that the water is now going to go out and in some time. Okay. If the inundation area is not cleared over a quick succession, then this area will be subjected to flooding. So when I'm going to do the drainage analysis of this, I'm going to check all these aspects. I hope this point is clear. Okay. Now, so when you do this particular drainage analysis, the major analysis which I feel very, very important for your landscape project site is, one is that it is the contour analysis, slope analysis and drainage analysis is very important. Now quickly I will go through the other analysis so that I can conclude this discussion now. Geological structure analysis is subsoil level. At the subsoil level, whatever is the strata that you are trying to find out, and at the then at the topsoil level, that I will come here. In the climate analysis, what you are doing is you are trying to find out the climatic factors which are affecting my particular site. So essentially what it is, like say it is as listed over here, the winter winds, the summer breeze, from which direction the summer breeze comes. Say this particular one is the white is the summer breeze. That means during summer the breeze is going to come from here. During winter the breeze is going to come from here. So basically what you are doing in the climate analysis is very standard, which you have done for your architectural projects as well, that you are trying to find out with respect to the site how the sun is radiating its rays to this particular site, which portions are the shadow zones, which portion are the lighted zone or sunshine zones. In terms of wind, what is the wind direction, what is the the frequency of wind flow. So wind velocity, the variations of the wind velocity in terms of which is represented in terms of wind rose diagrams, that you are going to check. If there is any wind shadow, that means an area which was supposed to get the wind, but because of the contours and the profiles, so you don't have that, so wind shadow zone. Or is there any wind tunnel effects, which is regulating the entire wind gently flowing but suddenly entering into your site through some crevices, and ultimately the velocity increases, there is a wind chill effects. So these are the things which you are going to check with respect to your site. I am not going into the detail of this, because for each one of them there are lots of discussion which I can do. Okay, these are only some representations, that is there any wind funnel, or if there is any south slope, if there is a prevailing wind, or if is it like say diverted prevailing wind. That means there must be something which is obstructing the wind and ultimately diverting. So this is only a representation. You are knowledgeable enough to find out exactly how the wind is behaving within your this particular site. Okay. Now once you do this, what will happen is automatically the same site analysis which diagram which had been using for contour, drainage and others, you can also do it for your wind, you can also do it for your sunshine, and then you accordingly decide with respect to say climate analysis, the position of my cottages at this location which can get good amount of sunshine most of the time of the day, then that is the best location. And I am sure that if suppose this is the wind radiation direction, and then you are placing, I will just show one, like say if suppose you have a profile of this particular site in section, and you have most of the sunshine period is here in this direction, I am sure that you are not going to put your cottages here, you are not going to put. You will always prefer that this is the area which will be subjected to sunshine and radiation for longer duration. So this becomes selected. That is how you do the selection, and you decide where all those functions. Essentially in this 2-3 things functions which are very much affected by the climate, that is, one is the location of the cottages, then also location of the plantations which is supposed to get the sunlight for its photosynthetic actions. So you are going to decide. The rest of the things you really don't have to, you don't have to decide about the road based on the wind or the sunshine, neither the overhead tanks, but the playfield you would, because the playfield has an orientation. In this what happens is, if suppose you find that your actually this is north, this is east, this is south and this is west. Suppose the profile is such that you have got your playfield orientation in this direction. Unfortunately, the profile of the land is such, in terms of slope analysis, you have found that this is your orientation of the field. This will become negated. The reason is that east and the west, when the sun is at a lower altitude, and if they are at the lower altitude, then they are likely to disturb the eyes of the players in this particular field. So that is why you will find that for in whichever games are being played in the daylight, those games, the linear axis, the longer axis is generally not aligned with east west, they are aligned with north south. But argument is that okay, at the south also we have the sun, but only thing is the sun goes at a higher altitude, so it does not affect the eye or the visibility of the person, never creates a glare or anything, because sun has gone into higher altitude. So if suppose you find that your sun direction is this, but your profile of the land is this, then this gets negated. That is how the whole thing has to be worked. These are typical diagrams of the solar radiations and the wind directions, and these are for architects and others, you have done it very frequently. Few more analysis which are important, I will just conclude that. Agricultural analysis. See, the landscape you are trying to create in an area which is already, if it has the agricultural potential, then should you be converting that agricultural potential to a landscape potential? Probably no. Why I am saying probably no? If you find that that particular potential is going to be contrary to the agricultural revenue generated, in such cases probably your suggestion as a landscapist would be that please don't disturb the agricultural lands, because it is revenue earning, it has a strong potential, strong fertility of the soil, and the soil quality is good, humidity condition of the soil is also good, so please don't disturb the agricultural land. This is one option, one way of solving the problem. Another option of solving the problem is that you can always say that yes, if it is of agricultural potential, let us do one thing. Some of the areas I extract or exploit the agricultural potential, and for that agricultural potential I would go for revenue generating crop, which is going to be a component in my landscape, plus just like orchards. If you recall that in the Cordova Mosque example in the Spanish garden, we have said that they have created a garden of naranjos. They have created the garden for one reason. The garden was mainly to provide shade to the people who came for the prayer. But why have they converted this to a garden of naranjos? Because they could have, the soil quality is so good that they could have good citrus fruits, and the whole garden has been designed in such a way that it provides shade, additionally the citrus fruits. Similarly here, if you find that the agricultural potential is so great that you can, some of the portions you can always extract and exploit as orchards, you can do that. So take that into consideration. In the vegetation analysis, basically what you do, let me explain. In the vegetation analysis, you are trying to find out the vegetative capability of the soil. So vegetative capability will be given with respect to the chemical properties of the soil. This I will discuss when I will discuss about the landform. More in detail I will discuss. Here I am trying to say that in the vegetation analysis, you are trying to find out the vegetative capability of the soil, the chemical property of the soil, and what is the density of the vegetation. For this, basically what you do is, what you try to find out in vegetation analysis is, what you are supposed to find out. I am again drawing a very arbitrary site. In this, suppose these are all plants, and then all these are nothing but location of plants. Each of the plants located. What you are trying to find out, what are the species? How many types of species are there? How many types? That you try to find out. If there are more than one, then what is the mix? That means what is the proportion of mix? How are they clustered? Then how is the density? How are they placed? Okay, and then you try to find out, see, if you have found out the density, suppose in this, if you take this particular area into our discussion, then you find that the density of plantation is high. What about this? Blank. So your analysis is showing this is the area which is very potential for plantation, this is also potential for plantation as per existing. Now you will check the soil quality of this area, and then you find out, are they also suitable for vegetation? If they are, try to find out, zone that out, and then you decide. In this, one more analysis that comes in when I am saying the soil, you are trying to find out the vegetative capacity in terms of finding out the existing species, how many types of species, mix, and the density. If suppose I say that you also check with respect to the soil quality, then what you will do is you will try to find out and make a zone map of this in terms of soil quality. I am just giving an example. Suppose you have found that this is the zone which is of soil type A. I am saying now with respect to soil. So basically I am clubbing the soil analysis and the vegetation analysis together, but you have to do it independently. And this is the soil type B, and this is the soil type C. Interestingly, soil type A is suitable for some kind of species, soil type C is suitable for some other kind of species, soil type B may be suitable for the other species which are also growing here. Soil type B may be very neutral, that it does not matter, it can take any kind of species within. So basically now what you have done is, in this you have done two analysis. So here, as you are doing vegetation analysis, do a separate soil analysis, and this soil analysis that you will be doing, one is going to suffice with respect to vegetation, and this is going to suffice with respect to your strength of the soil, and then decide. Okay. After that, this is another this picture, if you see here, this is another representation of the vegetation. Okay, but I am coming to the end of it. Very important analysis which you have almost done during your reconnaissance is the visual analysis. Let me explain this drawing look at it very carefully. Basically, in the visual analysis you are trying to create an isovist. Not everything may be very clear, but if you have a closer look, you will definitely, if you blow it up, you will see. Basically what you are doing, you have multiple levels, different contours, and you are trying to find out along the edge how is the visual potential, outwardly or inwardly. For understanding this particular diagram, you always try to visualize any hill station that you have visited. If you have visited a hill station and then you have walked along the edges of the contours, try to retrieve that experience and then look at this particular drawing. But there are certain things which has to be recorded. What? Can you see there is a thick line which is like this? This thick line. This thick line is called the visual horizon. Visual horizon is when there are two contours parallelly going. If you see that walking along this particular contour, you have a good view. Naturally, if this is the contour higher and the lower, then naturally the good view comes onto the lower hills. So if you find that in certain area this is the very strong potential you are getting, I'll just show with respect to one sketch here. Suppose you find that on this, starting from here to this, you have a good view potential downhill. This is high, this is low. Good view potential downhill. If you travel from here to here at the same elevation and you still continue to see that particular good view, then this particular stretch is called visual horizon, which is in this map, this line, thick line. If you find that from here again the view potential starts, but at the same contour line this does not offer any view potential, then there will be a thin line drawn, and this will be called as link lines. So visual horizon, next visual horizon linked with a link line. Now if you find at this particular point, if you step down from here to here, you have the strong view potential outward, and then you draw arrow like this. This is called visual watershed, which is in this particular drawing. If you see map, this is the kind of thing, visual watershed. This is the kind of thing. The arrow indicates in which direction the view is. Okay. Essentially, in this visual analysis, you have the visual horizon, you have the visual watershed, you have the link lines, and also there is another thing. Look at this map. This particular point, when you reach this particular point, you stop and then you look outside and you get a view out. Okay. Now let me draw. From here you have a view out. This particular point is called viewpoint. Now do you recall any hill station that you have gone to? You have seen there is something called viewpoint, and you traveled all the way along this particular line to come to this particular viewpoint to see this, and you did not stop anywhere else but came to this particular point. So wherever there is a view out at this particular point is called the viewpoint. Okay. Now that makes it very, very clear. Very, you have the side boundary. Look at this map now. I am again relating this. You have a side boundary, naturally any drawing that we will have. Okay. Then you have the visual horizon, you have the visual intermediate horizon, I will tell you, but you have the visual watershed, you have the views out, and you have the link lines. What is intermediate horizon? In case you find that there is a place, let me draw here in this, follow this. If suppose you have found that this is the visual horizon and suddenly at this point you have a zone which is at the same level, it can happen, and then this is the intermediate horizon, that means at the same level you can come here. These are the points where generally in the hill station you will find there are sit outs or gazebos people make it. That you come to this particular point, there is a gazebo here, you sit at this particular point and you see the sunset, sunrise, or the hills and other things. This is visual analysis. In fact, you will find when you do the reconnaissance survey, your visual analysis generates at that time only, and you start recording all these things. And the last thing that will now remain in this particular analysis is the laws and regulations. What you do is, if you follow all these analyses one after another, how do you collate? Each analysis is independent with respect to the different functions. Now you superimpose all these one after another, and whichever function you find has satisfied the maximum number of analytical position in this analysis, that earns the point, and that is the point at which it gets the location fixed. Okay. So that means if I see the overhead tank location with respect to all analysis is coming at the same point, then that is the overhead tank location. If you find that in one analysis the cottage is the best located here, in another analysis the cottage is best located here, now you are trying to weigh it, that which one gets the best benefit. Maybe slope wise this is better, but the thing is sunshine wise this is better, and sunshine is more important than the slope, because slope can be negotiated, then this one wins the race and this gets selected. This is how the whole thing is very, very analytically can be done. If I try to conclude this particular discussion, if you see during a site analysis and appraisal, you have fairly taken intermediate decisions and I would say tentative decisions. But when you really try to detail out the whole thing, you will find that 50% of your decisions are done at the analytical level itself. When you have made the appraisal and made the checklist and design criteria, 50% of the design decision has been taken. After this, if somebody takes it up, he only details it out. Try it yourself, you will realize this. Okay. Now, I will put one disclaimer on this. Do we every time start with all this detailed analysis before you go into it? Mind it, all analysis that you have done so far, whether it's landscape, design, or your personal decisions, you have gone through a process. Only thing is you have never recorded. You have not done it sequentially, neither you have recorded. So to save this process, let me ensure one thing. This is the process which I have theoretically and very systematically explained to you. Even if this were not given to you, if you make a landscape plan, you will find that you have been doing the same thing at the back of your mind, but not through the process. So my suggestion is, when you are doing a very technical professional work, do by process, follow the process. I hope you have understood what I have tried to communicate to you. Please go through it in detail, study more, ask me more questions through forum, so that I can clarify in case you have any iota of doubt in your mind. Enjoy the course. Thank you very much.